you want.
Well, hello, my name is Jairo. We're Group 8, and we're going to talk to you about the circuit breaker, which is a pattern used in software. Oh, no tenías que pasar. Bueno, which is a pattern used in software development. We're going to explain to you what is it, what it is, how does it work, and several matters we should take into account before and during implementation. After that, we're going to show you a sample scenario so you can more or less understand how it is used in the real world. But first of all, what is it? The circuit breaker pattern, as its name says, works more or less the same as an actual electrical circuit breaker. When in our home, for example, we have any problem, for example, a short circuit or too much current, the circuit breaker cuts the electricity to avoid further problems, for example, a fire. We should have this too in software. If we are having a problems, for example, a call is unresponded for a lot of times, and our program is stalling, we should avoid this for improve the user experience. So the circuit breaker, if you can pass the slide, changes the state of the system in order to make it unavailable for the calls and avoid these timeouts. Here I have some pseudo code I wrote. Is more or less Java, but it's not real code, to show you how it works. When the client code calls any service, external service, for example, the circuit breaker is by default in a closed state. It means it accepts the calls. So it does the call and returns the expected result. If this call fails, we update a counter of failures. And with a failure threshold we set, we can check how many, excuse me, how many times the program has failed and change its state to open. When it is open, it automatically refuses to answer the call. But we cannot stay in open state forever. So we have a timeout, and when it reaches the time threshold, we change to a half open state. What does it do? It checks if we can do the call and have a successful result, and if it can't, excuse me, stays in open state. If the call doesn't fail, closes the state again and accepts the calls.
Okay, so now we have explained the way it works. We are going to tell about some aspects we need to take into account before implementing a short circuit. First of all, we need to take into account if it will really increase our system response capability, as it wouldn't make sense in some other system to not implement it. For example, if it's possible for our dependencies downstreams to get overloaded, because if we know that our system doesn't have enough users to get overloaded, it doesn't make any sense to implement this kind of patterns into our software. And if overloaded, we don't know if reducing the requests for the overloaded downstreams will help to recover it. So in that case, this kind of pattern wouldn't make any sense. As well, we need heuristic rules for open and closing the circuits, which could be based on time or some kind of triggers, depending on the business logic for the software. And our system could also produce some kind of high correlated errors. In that case, it will make more sense to implement, for example, a fail first pattern, which is highly correlated with this one. Following, we need to take into account if it's possible to deploy this kind of break sequence into our system. First, we need to define properly a maximum load dependency that our system may handle, and to tune correctly the circuit breaker. We will explain this in the following slides, but this kind of patterns can be quite dangerous if we don't tune it correctly based on the requirements of our system. Also, we need to monitor well the effects that this pattern is having in our system, because we need to adapt it if we see that it's not working as correctly, and we need to rebuild it in the future if we see, for example, that is not functioning as it should be. And also, we need to take into account the maintenance cost of this kind of software. It's really important to always periodically plan a routine to remeasure the dependencies and the maximum load, because as our system may increase, the loads can get better, so we always need to readapt the pattern that we have implemented so far. Following to the next slide. As my colleague Jairo has just explained, this pattern can be a really useful one for self-healing software. It can prevent many kind of errors for overloaded systems, such as we can see the thundering hertz or the out-of-memory error. Just as a note, the thundering hertz are a kind of error that appears when many threads or processes are waiting for an event to be awakened, and once that event awakes, all of the processes go to try to respond that event. So at the end, they just consume all of the resources that our system may have. The important considerations during the implementation, if we want a good working for pattern, first of all, we need to adapt correctly the threshold based on our system requirements. We need to adapt a maximum time for the circuit to be open. As I hope it makes sense, if we keep our circuits open for too much time, the pattern wouldn't make any sense, because all of those processes will just be consuming the resources of system. We also need to configure exceptional trigger for closing our circuits, not only based in time, but based in other kind of exceptions. For example, if we detect some kind of data we don't want to be able to access our downstream services. And if it's possible, we all need to configure each constraint, which I have just explained, 3 of them. We need to configure each of them for per environment, per endpoint, and if it's possible, per request. This will be only necessary if, for example, for the same request, for different requests in the same endpoint could return us different values. We need to personalize the time and the maximum threshold per each of all of these. And following to the next slide, we could see the consequence that could have wrongly configuring the thresholds and the constraints that I have just explained. The first 2 of them are the most obvious ones, and they will be left because of a bad estimation from the team in charge of configuring and stabilizing the thresholds for our pattern. For example, if we settle or wait or opening times for the circuit too much time, the system rate could be strongly decreased. And in the other way, if we close them to short time, our system could exceed the time of resources it's consuming from our system machine. Also, there are some kind of unexpected errors that can be produced from the circuit breaker, and there are some confusion in downstreams due to episodic request patterns if we don't configure them properly and we allow the circuit breaker circuits to keep calling down and down stream services. So we could have another kind of error in that way. And that would be the consequences of our own implementation.
Okay, so sorry. So my teammates have very well explained what the circuit breaking pattern is and how it works. But despite their brilliant performance, you still may not understand completely its applications to solve real-life problems. And that's why I bring you here a typical scenario that many of us can possibly face at some point of our future professional life. So let's imagine that you work for a as a software developer for a company and that you have implemented a system that allows users to check data from your customers to be used in any matter or way. When you developed this system, you decided to use an external API to list the customers and display their details when they are selected. As we are all obviously very skillful programmers, the application is flawless and works perfectly fine. But let's put us in the situation that one night the phone rings, there's a problem with the application and nobody can access it. You rush to your laptop, navigate around the application logs, and you find it. The system providing the API is unresponsive, and all the requests to the API timeout after 30 seconds. And to make it worse, users keep on sending calls to the API trying to use the system, which cause your servers to consume its resources, which would lead to a flooding that would be catastrophic. What can we do? Well, here's where the circuit breaking pattern can help. This would be a system through which API calls go through that continually monitors for failures. In the case that there is a timeout failure, the system moves from the closed state in which all cores are available to pass through and reach the API to the open state, which, as Jairo explained, acts like an open switch in a circuit and does not allow any request to reach the API. This occurs automatically when the service exceeds a failure threshold that we have previously set. When the system is in this state, the server does not overload and you have time to figure out a solution or at least warn users about the system being down, improving their user experience. After a time, we enter the half open state, in which will let a request pass and evaluate its result. If the call goes through and succeeds, the circuit breaker will close again, allowing the application to keep on working. And if it doesn't, it will return to the open state, preventing the system from overloading until the issue with the provider is solved. This way, the infrastructure is safe from being stalled, waiting for the system that is down, and so your resources are not being pointlessly consumed. I hope that with this example, you have all a clear idea on how this kind of pattern works. And here we end our presentation. Thank you for your attention, and you are very welcome to ask any questions that you want.